So you mentioned about doing data visualizations or making them better looking than the initial ones we worked on. So I'll cover some of that, and and then I'll bring up this R commander, and I think it might help some people that are having trouble with the programming side because it creates a GUI for you to run code with. Unfortunately, when you get to the next class, though, you can't run the more advanced models with the R commander. So we'll start with, I uploaded this data set. It's an Excel file. I got the data off of Kaggle. It's just, I think it's called Big Data Mart or something like that. It's just some like store type data and like a grocery store data. But there was a good website on how to use ggplot multitude of different ways. So if we load that library, and then we use the data set provided, there's several ways we can run our different scatter plots. So this is kind of what we did with our scatter plot in the last one. I think this is the items, it's like maximum retail price, and then how visible a product is on the other axis. But the problem with the scatter plot is it's just black and white, so you can't really differentiate the different products. So the first thing we can do is add color to the different products, which is what this second set of code will do. There. So that's it zoomed in. And now we can see like this red dot is baking goods and how they are distributed based on their maximum retail price and the visibility. So those two variables. The third breaks it down by category, so we can have multiple scatter plots broken up. So we started with just a basic scatter plot, then we added the colors to differentiate them, and now we've created a scatter plot per category.
Each of those, there's the same two variables, the visual and the manufacturer's retail price?
Yeah. So retail price by visibility. And so each of them display the same information, but 3 different ways. So I think this one's probably the easiest to understand if you were to like present it to somebody, because it breaks it down by category and keeps the data separated in a way you can point out each kind of food and how it's how visible it is versus its price. So then we talked about histograms. Back to just a count by its retail price. But you can also look at it as a bar chart. This is always zooming out. So it would count by the year that the product was placed in the store, I think. This one, the second set of code is just looking at a vertical bar chart, but this one has a stacked bar chart. We wanted to run that differentiates it by the type of supermarket that it is, and which tier it's in. And don't know if we talked about box plots before, but it just shows our descriptive statistics in a graphical way. So you'll have your, that's not the one I wanted. Box plot. There. So we have our outliers and our min and max and our median and our mean set up here. But you can get that information from just summary statistics, which we'll talk about a little bit when we switch to R Commander. The one I thought would be most interesting, though, is a heat map. You may have seen this in other. So depending on the color, the brighter the color, the higher the price. This is the type by the outlet, the kind of store it is.
What are you looking for on this kind of, like if I use this type of chart for this, what is it? What kind of intel can I get from it? Because it looks like a Minecraft block.
Yeah, it does kind of look like a Minecraft block. You can make it look visually different, but basically, the lighter the color, the higher the value. So it makes it where you can compare different goods by their outlets. It looks nice, but it's not one I typically use a lot. But I've seen it a lot on like dashboards, when you are like executive dashboards. But I just wanted to show a few different ways to use the ggplot function. Now, the other thing I wanted to bring up is the R Commander package. So this is the code you use to install it. You need to put the dependencies equals true because otherwise it doesn't install correctly. When you try to run it, it won't work right.
What is the dependency?
That just makes sure it installs all the necessary dependencies for this particular package. First time I tried to run it without having the dependencies are on there, it was missing something like, what was it? X quartz or something like that, I think was the dependent package that it didn't install. So this just fixes that problem. So then you open that library with this, and then you type commander function, it will open up this GUI here.
So, Professor.
Yeah.
You're posting all these on the website because I really don't have video tonight to watch it.
Yeah, I'm recording this.
Okay. So I'm stuck in traffic.
No problem. Yeah, I posted some other videos, and then I'll post a recording of this. It usually takes like an hour or two to upload after we finish. So after you install the R Commander software, you'll get this graphical interface, and you can pull in your data set here. We have the iris data set, which is just a kind of a default one to use in RStudio. You can edit your data, so in case it brought in the wrong file name, it's easy to change it here. If some of the data is wrong and you need to fix it, you can add a row or a column. Yeah, if you just want to view the data set, it's the same commands if you just use the view from the command window, but this just allows you to view it from with clicking. If you have a model, which we haven't developed any models yet, you can pull in models. What makes this easy to use is if you want to run like summary statistics, go here, it will run it on the entire data set. So for this data set, we have sepal length, sepal width, petal length, petal width, and then the species is the dependent variable. And these are just counts. So we have 50 values for this species of iris and 50 for the second one, third one, etc. Gives us our min, our max, our mean, median, and our quartiles. The second one, if you come to numerical summaries, pick field control, you can pick all of them, and it will give you the mean and the standard deviation, as well as the quartile ranges. So, and if you have the standard deviation is the square root of the variance, so you can get the variance from there too. I haven't found that it calculates it from here, but if you use the var command or function, you can get variances. Now the rest of these are actually tests that you can run. Let's see, make sure I run correlation matrix. If you, as part of your assignment, you have to do a Pearson's correlation. So if you want to look at the correlation between the different variables, you select all the different variables and you'll get a correlation table here. And you should always have ones on the diagonals, and then you can see that this data is highly correlated. So
Does it
after
do
that,
does this
yeah.
R commander, it does the graphs too?
Yeah. So if you wanted a histogram, it'll run that scatter plot. So, and it generates all the code here and then runs it in the command prompt. If we do, let's say, box plot on, so let me do one. Pops up here. So it generates it for you, but like I said, this is useful right now, but when we go, when you take the data mining class and we have to program more advanced algorithms, you can't use this graphical interface. So in the meantime, it's helpful, but in the long run, it's better if you learn how to code these, but this will at least generate the code for you. Then we get into, let's see, what's the other one? An ANOVA. So one-way ANOVA, if you wanted to decide if the means are different based on petal length, you'll get your ANOVA results. It'll say if this was a hypothesis test, you were hypothesizing that all the means for the different species of this iris are equal. And basically what this ANOVA, one-way ANOVA tells us is that because the F test is less than, it's a very small number, it's very significant, that these means are not the same. So you would reject the null hypothesis, and you can see that they're not the same because they're down here. So that's how you would do the ANOVA hypothesis test using R Commander. It has separate hypothesis tests, but that's only a single sample, and we're not testing individual means, we're testing groups. So ANOVA just makes more sense. The data we're typically going to be working with. Down here is fit models. Over the next couple of weeks, we'll talk more about like linear regression, which is, and you can use linear regression here or generalized linear model. If we wanted to predict the species based on sepal length, then we could run a linear model based on that. But
This
that's
is
how you do it.
the one you just had. That's just a regression model, right? It's not.
Yeah, just
like
a simple.
Or any of that machine learning stuff.
No, it's not. It's just simple linear regression. I mean, I wouldn't consider it machine learning, but I think generally they start machine learning classes off where you learn like logistic regression, and then you build off of it.
Okay.
So yeah, it'll create the code for you. So if you end up having to go this route, this is the one I would use because it's just the GLM function, which we're going to go over when we do regression on the hospital data. Oh yeah, there was one more graph I wanted to show you, the 3D graph. Pick two, pick some options, but already created. So basically, you can create some pretty cool visualizations in 3D, but it looks at the three variables, and then I've added some either residuals or different regression fittings on there, but see if it'll let me edit them. Let's go. There. That would just be a plain one. I like it better with the black background, but all the options are here. There. So I thought if you were looking for a more interesting or better visually appealing way to make a visualization, the R commander makes it really easy to do 3D plots.
What kind of file is that? Could you save it as like a JPEG or? I mean, how do you input that in like a document to show?
I think in here, let's say graph to file. So, and then you'd have it. Probably my concern with that way though is you end up, it depends on how it's oriented.
So you can't orient it once you save it. You orient it and then save it, and it takes a snapshot of it.
I think so.
Okay.
Let's see. Say the other thing I wanted to bring up was, let's see if I have the, I have a set of books. If you're interested in different Python and Hadoop data science, Apache Spark, which is pretty popular, some Python books. Then I have a whole nother set like this that's all Python for data science. But
what is Hadoop? Because that was the term I learned a couple weeks ago, and I haven't really.
Hadoop is like for distributed database. It's got, what is it, MapReduce, and what's the other term? But I can point you to some material on that too. That'll just gives a basic overview that I make my undergrads look into. But it's Hadoop is for big data, and how it's a different way of how data is stored.
Oh, okay. Is it in SQL or is it in its own language?
It's got its own language. Let's see if I have the so cognitive class has this big data 101 class. This was developed by IBM, and I think they sold it to somebody else. But the second set, or the second class you take here, is on Hadoop. So it only takes about 5 hours, and it's just kind of like an overview of what Hadoop is. trying to pull up. Oh yeah, okay, here we go. So when you guys start working on your assignment, there's something I want you guys to start to think about. So you have this set of variables, which we've talked about before, but if you've noticed, we have these 7 variables, but which ones are you going to use, or what would be your dependent variable? That's what I want you guys to think about. Because we have 7 independent variables, but what are we predicting?
We're trying to predict the amount of patients that come in and how many beds we need, and if we need more.
Yeah. But we also have this data, so I think you guys should look at, it doesn't match up perfectly, so it's going to take a little bit of work, but you have your NEDOC score. So you might want to create a variable to add to this data set that you could use this to help predict something to deal with this. So,
On this data set you guys showing right now, the components data, the date and time, is that every 15 minutes as well?
no, that's every hour.
Every hour, okay.
Yeah, so that's what makes it kind of difficult. You'll have to think of how you're going to solve that problem and explain it. But yeah, it was recorded every 15 minutes for this set of data, and only every hour for this set of data.
Can you do some kind of join and have the every hour be repeated 4 times and have a different NADAC score?
I'm sure you could do that, but there's other ways you could think about it if you wanted to like take the average for, we have it recorded. You could say for this particular hour, it was the average of those 4 values is equal to the components data here. Or you could make it really easy, and you could make like a binary where if it's under 100, it's 0, and if it's over 100, it's 1.
Oh, okay.
So, I mean, that's what I want you guys to think about, that is how are you going to connect these 2 pieces of data.
And did you want us to connect the third one too?
That takes a little more work. If you're able to, then that's great, but you're going to have to calculate out the throughput times yourself, so you'll have to find some way to get the distance between those 2 times, and then explain, or how can you add that into your model to have throughputs associated.
Okay.
So I mean, ideally,
so by the third data set, you mean the one with I'm doing the patient flows?
yeah.
Okay.
So I mean, I've put all the data there. Ideally, you would use all the data, but depending on your level of what you're going to accomplish in the short amount of time. But you're definitely going to, what I want to say first is these are all independent variables. So you could develop a model, but you need to think of, we're going to need to build a predictive model, so we need to be predicting something. And so that's why I thought to bring up, you should probably connect it to predicting something to do with the NEDOC score, or crowding in general. So I was giving some ideas, like if it's less than 100, then it's 0, so it's not crowded or overcrowded. And if it's greater than 100, then that would mean it's overcrowded. And then you'll get your regression coefficients, and you can see how they affect, if they're significant, and what would be the rate of return, or your odds ratios, depending on which kind of regression we do. But we're talking about regression over the next 2 weeks, I think.
Now, real world practice, do they run different types? Because you said something about the average between the hours, the greater or less than 100. Do they run would go through and do different things to see whatever they want to see?
You would come up with different ways to analyze the data, and then as long as you can defend what you're doing and explain it to somebody, then that's generally what goes on.
And in terms of our project, our goal is to find a model that best supports our argument.
Yeah, that's why I said in the first paragraph, I say there's really no right or wrong answer. It's just you need to be able to come up with a model and then explain it and defend why you think whatever recommendation you're going to make to the COO.
Okay.
So, you guys feeling comfortable with the project? Is there anything else you want to know about it?
The assignment that's due this week, do you want us to kind of just send you the charts, or are we doing like a?
I just so this assignment this week. Let's see if I have the. So this part, I just want to make sure you can do this set of functions on the data. And then the second part is you have to write a brief report, so like 1 page, kind of updating the chief operating officer on what you found out and what you think, and try to answer some of those questions that you had in assignment 1. So think of it as you're going to a meeting. In the first one, you were given a problem and you had to look up background. Now you're learning about it, so you're giving an update. Then you're going to do your model, and you're going to finish off explaining what the COO should do. Right now, we're just kind of at the descriptive analytics phase. And then on the next one, we move on to predictive analytics.